Now that you've learned all of your trig functions, it's time to learn the reciprocal partners. What? I know. Yes, there's always more in trig to learn, so come along and I will teach you the trig reciprocals. Once that you learn all your trig identities, then the next thing they're going to throw at you is the trig reciprocal identities. And a reciprocal in math is just a number divided by that quantity. So I'm going to show you what all these mean today. The first one we're going to look at is we're going to look at sine. So the reciprocal means one number divided by that quantity. So here's sine of alpha. And this CSC, I'm going to put in a thought bubble here, stands for cosecant. So cosecant is 1 over sine. That is your reciprocal identity, which means over here, sine actually equals 1 over cosecant, and this is that alpha letter to represent an angle. So what you have to remember is that sine in SOHCAHTOA is opposite over hypotenuse, which means your cosecant is going to be the reciprocal of that. It means it's going to flip. So cosecant then is going to be your hypotenuse over your opposite side. And obviously this is when we're talking about a triangle, which we're going to do some examples next. But first I want to make sure you got this down. Okay, so next let's talk about cosine. This one is called secant. So secant is actually 1 over cosine of alpha. That's just our angle. So then this, the way you pronounce this, is called secant. So cosine over here is actually 1 over secant of alpha. And remember, cosine is opposite over hypotenuse, which means secant is going to be your hypotenuse over your adjacent side. And if you don't know where these are coming from, make sure you check out my other video on how to use SOHCAHTOA and labeling the sides of a triangle and finding your trig functions for that. Now with sine and cosine, here's a little trick to help you remember the reciprocals. Sine starts with an S, but the reciprocal of sine starts with the C. So if you think about reciprocals, you can think, well, it's not going to be the same letter for the reciprocal. And the same thing with cosine. Cosine starts with the letter C, however, its reciprocal starts with the letter S. Hopefully that will, in your mind, you'll just have to remember, because it's reciprocals, it's going to be the other letter. Now let's take a look at tangent. Tangent's reciprocal, so 1 over tangent of alpha, is what they call cotangent. So cotangent, which means tangent's reciprocal is 1 over cotangent. And then remember, tangent on SOHCAHTOA is opposite over adjacent, which means cotangent over here is going to be adjacent over opposite. Now that we know all the reciprocals and how they work, let's try some examples on the unit circle. All right, we're going to do some examples finding cosecant, secant, and cotangent of the following angles. If you're not sure how to find these angles on the unit circle, check out my video that teaches you how to do that. And if you're not sure how to use SOHCAHTOA, we've got another video that teaches you how to use that with your regular trig functions. Because now what we're going to do is we're just going to find the reciprocal of those trig functions. So pi over 4 is in quadrant 1. That is a 45-degree angle, which means our side labels are 1 square root of 2. So now we're going to find cosecant of pi over 4. And remember, cosecant starts with the C, which means its reciprocal is sine. Sine is, remember, you're always standing in the corner. Sine is opposite over hypotenuse, which makes cosecant hypotenuse over opposite. And of course, that will reduce to the square root of 2. And then, of course, now we'll find secant of pi over 4. And remember, secant of pi over 4 starts with an S, So its reciprocal trig function is cosine. Cosine, standing here, is adjacent over hypotenuse. So then we got to do it the reverse order. So we're going to do hypotenuse over adjacent. So again, is the square root of 2. And then the last piece that we need to find is cotangent of pi over 4. So cotangent of pi over 4. So remember, tangent is going to be opposite over adjacent, which is 1 over 1. Well, for the reciprocal of cotangent, we flip it, which is still 1 over 1. So we get 1. So here are your 3 reciprocal trig functions for pi over 4. All right, let's look at the next problem. 3 pi over 2. Do you remember where this is on the unit circle? This is at the bottom right here, 3 pi over 2, right? Which is the ordered pair, 0, negative 1. This is our xy pair, and remember, x is cosine, y is sine. So if we're going to do cosecant of 3 pi over 2, we have to remember that cosecant is 1 over sine. Okay? So we have to remember sine is our y value. Our y value is negative 1. So it would be 1 over negative 1, which gives us a negative 1. Now let's do secant of 3 pi over 2. Again, secant, remember, starts with an S, so his reciprocal is cosine. Cosine over here is our x value. So it's 1 over our x value. Wah, wah, right? We have 0 on the bottom, which is no good. So this one is actually, you can write 0 with a line through it, or you can write undefined, because you cannot divide by 0. So now, let's try cotangent of 3 pi over 2. And remember that cotangent is 1 over tangent. So what would tangent be over here? So if you remember, tangent is y over x. But now we need 1 over y over x, which is going to really flip that, right? So cotangent, if you think about it, I'm going to put my thought bubble here, is actually x over y. Correct? Because tangent is 1 over tangent, which is this. We have to flip it to get cotangent. So our x value is 0 over negative 1. And with 0 in the numerator, you can do 0 divided by negative 1, which gives you 0. So remember, when 0 is in the denominator, you cannot divide by 0. It is undefined. But when 0 is in the numerator, your answer will be 0. You can divide by 0. Now let's try one in the pi over 6 family. 5 pi over 6 is over here in quadrant 2. So we have 30 degrees in the corner. And our ratios are 1, square root of 3, and 2. However, remember, we're to the left of the origin, which means this guy has to be negative, okay? Sometimes that's the biggest mistake, is you're forgetting where you're at in the origin, and on the xy plane, you have to remember that negative sign. So cosecant of 5 pi over 6 equals, okay, so remember, cosecant starts with a C, so the reciprocal is sine, which starts with the S. You're always standing in the origin. Sine is opposite over hypotenuse, so we got to flip that. So hypotenuse over opposite, so cosecant is 2. If we do secant of 5 pi over 6, secant starts with S, which means the reciprocal is cosine. Cosine is adjacent over hypotenuse. So now we're just going to flip those. So hypotenuse over adjacent. And you can leave your negative sign in the denominator. You can bring it off to the side or put it in the numerator. And then cotangent of 5 pi over 6. Again, reciprocal of cotangent is tangent. Tangent is opposite over adjacent. So now we have adjacent over opposite, which simplifies down to negative square root of 3. All right, now let's try one in the pi over 3 family. So 4 pi over 3 is going to be down here in our third quadrant, because this is 3 pi over 3, 4 pi over 3, which makes this a 60-degree angle. Across, here's your 30, so across from your 30 is your 1, but negative 1 because we're to the left of the origin. Negative square root of 3 because we're below the x-axis, and then positive 2. So we have cosecant of 4 pi over 3. Again, cosecant starts with the C, so the reciprocal is sine. Standing in the origin right here, sine is opposite over hypotenuse. So now we're going to do hypotenuse over opposite. And then we have secant of 4 pi over 3. Starts with an S, so this reciprocal is going to be cosine. Cosine is adjacent over hypotenuse, so hypotenuse over adjacent, which simplifies to negative 2. And then cotangent of 4 pi over 3 equals cotangent. The reciprocal of that is tangent, so tangent is opposite over adjacent. So now we have to do adjacent over opposite. Both our negatives will cancel out, and you'll have 1 square root of 3. Now we have done an example of the reciprocal trig identities in the pi over 4 family, pi over 3, pi over 6, and on the unit circle on a coordinate point. You can use these to help you figure out any of those other problems in those families or in those groups. Now, just make sure you pay attention to where it's at on the coordinates and on your xy plane to see if any of the values should be negative. Hopefully this video helped you out. Be sure to subscribe and share with another friend that you know who's dealing with trig.